Today our topic is function generator. We have previous class discussed about CRO, cathode ray oscilloscope. So why we use CRO? We see that CRO used for measurement of frequency, waveform, amplitude. And today our topic is function generator. From the name it suggests that function generator generate a various type of waveform like sinusoidal, square waveform, triangular waveform, which we see in the laboratories. So if we see what is the internal block diagram of a function generator. So function generator, there is a first there is a external frequency control, and it is connected to a frequency control network. It's Here is a constant current source and here another constant current source. It is connected to a integrator. Integrator we use as a op-amp as an integrator, and our feedback resistance is replaced by capacitor in comparison with differentiator. Then it goes to a voltage comparator. If we take the output from the integrator, then we get the triangular waveform. We know if we use through a resistance diode shape circuit, then if we take the output of that, then we get the sinusoidal waveform, and if we take from here the output, we get the square waveform. So what is the important feature of the function generator? It's the capability of phase locking to external signal source. One function generator may be used to phase lock to the second of the function generator, and the output signal can be displaced in phase of the adjustable amount. In addition, function generator phase lock to the harmonic sine wave of another function generator. By adjustment of the phase and the amplitude of the harmonics, almost any waveform may be produced by the summation of the fundamental frequency generated by the function generator and the harmonic generated by the other function generator. So the function generator can also be used phase lock to the accurate frequency standard and also output waveform same frequency stability and the accuracy as standard. So if the function generator frequency range or generate sinusoidal, triangular and square waveform, we know that it's the frequency range 0.0 Hertz to 100 kilohertz. Frequency control voltage regulator of the two current supply sources I and I2 we have discussed, and we know the output of an integrator. Integrator output V out equal to 1 by C0 by Ti dt is we know from the op-amp circuit where we use integrator as a integrator, and C is the feedback element, and increase and decrease of the current increase the reduce the slope of the output voltage and control the frequency. Then it is connected to a voltage regulator. Voltage comparator multiplier changes the state of the predefined maximum level of integrator of the output voltage, and the current switches to supply source and supply 2. We are given that when the output attains a predefined level, the voltage comparator again the changes state and switches the supply source 1. The output of the indicator is a triangular waveform. We see that we get at the output as the triangular waveform here, and if we see that the same resistance of the diode may change, then the amplitude will produce sinusoidal waveform, and if we take the from the first output, we get the square waveform. So these are the function generator. We conclude that these are the generator which can generate various type of waveform. And another point is signal generator. Signal generator, from the name, what is signal generator? Signal generator is a name suggests that is generate of signal of many electronics instrument. So it's used for generator, like oscillator can generate the signal. So what is the difference between, anyone tell, the oscillator and the signal generator? The main difference is the two instruments are, when the signal generator are employed for producing unmodulated sinusoidal waveform, they are set and produce an continuous wave, height wave signal. When the produced output signal is modulated, the modulated waveform may be either externally applied sine wave, square wave, triangular pulse of complex wave, as well as internally generated sine wave. Signal generators are primarily employed for providing appropriate signal for calibration, testing, troubleshooting of the amplifier circuit in the communication electronics such as radio and TV amplifier. They are often employed as power source for the measurement of gain, bandwidth, SNR ratio means signal to noise ratio, standing wave ratio means SWR, and other properties of the circuit. They are also employed for measurement of characteristics of antennas and transmission lines. So if we see the block diagram of a AM signal generator, means amplitude signal generator. Amplitude modulation, we get the first is RF oscillator. RF oscillator means radio frequency oscillator. In for it is frequency adjustment. Then is goes to the buffer amplifier. Carrier frequency signal. Then goes to the frequency divider for range selector. Again there is buffer amplifier. Then it is connected to an output amplifier. Then it is connected to attenuator. We get the output modulated signal. In the output amplifier, we use modulator oscillator for frequency changer and wave shape selector. So RF amplifier oscillator, which is used for generating a carrier waveform whose frequency can be adjusted typically about 100 kHz to 30 MHz. Carrier wave frequency can be varied and indicated with the help of the range of selector switch. So we see the selector switch select the how many frequency range we have to require. Then the frequency stability of the oscillator is kept very high at the all frequency. And these are the following stable condition. We take the frequency of the output changes with the change of the supply voltage. Regulated power supply is used. Buffer amplifier then we use for isolate the oscillator circuit from output circuit, so that an oscillator circuit output can change the circuit connected at the output does not affect the frequency and the amplitude of the oscillator. Temperature also change the oscillator frequency, so temperature consistency devices are used. Q factor of the LC circuit should be very high, so that uh, above 20,000 because achieve the crystal oscillator in place of LC oscillator. And the audio frequency signal is generated another very stable spot called modulating oscillator. The position of the modulating oscillator changing the frequency and the amplitude of the signal being generated. In this oscillator position made of various type of waveforms, square, triangular, pulses. So the radio frequency and the modulation frequency are fed to the wideband amplifier called the output amplifier. Percentage of the modulation can be adjustment by the meter, which we see that the meter here the for adjustment, and modulation level can be up to 95% of the control device. The output of the amplifier that the attenuator are finally goes to the output signal generator. Output meter is read for the output meter is read from the output signal. Attenuator are employed. Why we use attenuator? Attenuator are used for signal generator capable of adjusting output voltage level 1 microvolt to 2.1 volt. The range in the excess of 100 dB. Both the resistive and the waveguide attenuator are employed as the frequency not exceed above 200 MHz. But a higher frequency waveguide attenuator are commonly employed. Why we use the resistive attenuator are generally used for standard signal generator and commercial design covering broadcast of the short wave. A reference input level to the attenuator is established. Either TVM or a thermocouple meter can be for this purpose. The accuracy of the frequency RF oscillator is known as the important specification for signal generator performance. Most laboratory type of instrument calibrated within 0.5 to 1% of the dial setting. So the accuracy is the sufficient for most instrument. For greater accuracy it's needed crystal oscillator for known as 0.005% beta for internal RF calibration source. Another key feature of signal generator is amplitude stability. It is the important feature. What is the important feature? Amplitude for the constant of RF frequency is vary. So audio frequency signal generator makes the use of audio frequency oscillator, typically RC type. The output of the oscillator is the adjustable resistive attenuator. TVM is employed for reference level of the indicators such as generator are used for determining the application of the frequency of the amplifier. So these are the two laboratory instrument. We get the function generator and AM signal generator. These are the broadcasting we use for generation in laboratory instrument. Another we use frequency heterodyne oscillator. Why heterodyne oscillator? There is a oscillator suppose they generate 1 and frequency 2, and another oscillator suppose generate f2. So if we take a mixer, then we get the filter, then you get the difference between f2 minus f1, then again it is passed through a attenuator, we get the output. So what is happen here? It gives the continuous waveform range of signal instrument. The signal quality good, but the frequency is the poor, and especially at low frequency. This is because output is the difference between f2 minus oscillator 2 minus oscillator 1, where the one of the all frequency are each cancel close to each other, and wide difference of the output cancel an amount of noise and the precious signal we get. So another we get here the advantages of function generator and signal generator, which are the most laboratory instrument. We get the details today from the class.